All right, from kinetic, we are going to look at the thermodynamic aspect of bromination and chlorination. Right? Again, we're not talking about iodination and fluorination. Those two, either one can handle it or it doesn't work. All right. So in laboratory, we just work with bromination and chlorination, and this is what we found. So one of them going to be faster, the other one going to be slower. But how though? Let's take a look. Okay. So let's take a look at the bromination real quick. All right. If you draw the mechanism, this is propagation. So, but by the way, to determine who's faster, we look at the activation energy. Right. So this, of course, I show you right here. So bromination is going to be slower than chlorination. But how though? How do you explain it? So we're going to look at the rate determining step. All right. So in the propagation of bromination, that's a rate determining step. The first step is hydrogen attraction. One more time. So propagation, I have a radical attack non-radical. All right. So bromine will form bond with hydrogen, and another electron here stay on the carbon. So you get this compound and this compound, the radical and the non-radical species. Okay. And this guy will go make product by adding react with the bromine. It's just a propagation. You do this together from the product. The first step here, if you do the same calculation we did earlier, is plus 42 kilojoule per mole. It's non-spontaneous, the first step. But the second step is negative 92. If you sum it up, it's 50 kilojoule per, negative 50 kilojoule per mole. So overall, the bromination is spontaneous. Only the first step is endothermic. Okay, it's non-spontaneous. I'll take a look. The first step right here, which is a rate determining step, from the energy level of the starting material up to energy level of the intermediate, which is the radical, you need to apply plus 42 kilojoule per mole right here, 42 kilojoule per mole. The activation energy is even higher. Okay. And the second step is negative 92 down here. Activation energy is a little, not a lot. All right. So that's the bromination. All right. Let's compare this with the chlorination. Right, two steps, same step there. Right, draw the mechanism exactly the same. So first step is negative 21 kilojoule per mole exothermic reaction. Second step also negative, so also exothermic. The overall much more exothermic reaction, exothermic than bromination. Let's take a look. So the energy difference between starting material and the intermediate on the first step. So here to here, that's negative 21 kilojoule per mole. Activation energy is small. Right. The second step, the energy difference, big, negative 96. Activation energy also small. Right. Now compare the activation energy between bromination and chlorination. Who's faster? Totally bromination. Okay. So no, bromination slower, chlorination is faster. Got confused. Chlorination faster. You correct. Sorry, my bad. So chlorination is much faster. Right. So remember that. Now. Fast doesn't mean good, not necessarily, right? It doesn't mean good. We're going to talk about the selectivity of bromination and chlorination.